Hi Jacob, I thought it'd be faster for me to make a quick little video rather than me try to explain it in an email, so here we go. What you need to realize is that these bars around a number or any kind of algebraic expression represent the absolute value. And when you take the absolute value of something, it automatically will make it positive. If I take the absolute value of 7, it's going to equal 7. But if I take the absolute value of a negative 7, well, it's still going to be 7. So think about that if you have the absolute value of x equals 7. Well, x, and so when you separate it and you have to solve it twice, what the main thing that I think you're not catching is that when you set up your two different possibilities, the absolute value is gone. If I'm trying to solve this for x, I'm going to set up two situations. I'm going to say x is equal to, well, what are my options? Well, it might have been just regular 7, like it was up here, or there's a possibility that the x could have been a negative 7, like it was right here. But notice here that the x no longer has the absolute value on it, which means you're setting up possibilities of what just the x itself would have been without the absolute value on it. So let's make it a little trickier with that idea in mind. Let's say we have this algebraic expression caught up inside the absolute value. The only way that the absolute value of this 2x plus 3 equals 4 would be as if just inside the absolute value, just the 2x plus 3, possibly equaled 4, and then we took the absolute value of it, which didn't really do anything, and it stayed equaling 4. The other option would be for 2x plus 3 by itself to have equaled a negative 4. And then when we take the absolute value of it, it went back to positive 4. These are the two situations that you have to allow for. And then you would solve each of them individually. So x could be 1/2. Over here, when I subtract the 3, x would be negative 7/2. Both of those would work if I were to plug them back into the original equation. So let's try it. If you take 1/2 and plug it in, 2 times 1/2 is 1. 1 plus 3 is 4, and the absolute value of 4 is 4. The other option would be to take negative 7/2 in here, and 2 times negative 7/2 would just be negative 7. Plus 3 would be negative 4, but when I take the absolute value, it goes back to a positive 4. I think the biggest issue was that you have to think about when you're setting up your two situations that the absolute value is no longer there. Which is why right here it was okay to say that it was negative, because it doesn't have absolute value on it. So the second part of that question that you had for me said, well, why about that no solution thing? Like on this example where you have the absolute value equals a negative 2, I can't just grab each one of these and put them down here and set up my two situations like I did previously and make one positive 2 and one negative 2, because it doesn't matter what I plug in for x, and then I take it times 3 and subtract 1, as soon as I do the absolute value, it would force it to be positive. So there is no possible way I can take the absolute value of something and let it be negative. And you kind of need to recognize that. Well, you know what, let's try this real quick. You could check that. You could say, all right, 3x minus 1 equals 2, or 3x minus 1 equals negative 2. Add the 1, 3x equals 3. So one of my solutions would be 1. If I did it over here, my other solution would be negative 1/3. But if you were to check these back in the original problem, if you plugged in a 1, so 3 times 1 is 3, and 3 minus 1 is 2, And when I take the absolute value of 2, I get 2, not negative 2. So that doesn't even check in the problem, so I couldn't use that as an answer. And the same thing would happen with my negative 1/3. If I put in the negative 1/3 right here times a positive 3, I'd end up with a negative 1. Minus 1 is negative 2. When I take the absolute value, it would take it back to a positive 2, and this would not end up negative. So this one wouldn't check either. Now, what they're trying to do is save you doing all of this work here and then checking your answer and finding out that it doesn't work. Anytime you have an absolute value equal to a negative number, it's not going to work out. And you can just immediately jump in and say, oh, that's not going to have a solution. All right, I have one other thing. Here's an absolute value equation that equals a negative 2. And so your first instinct might be to say, oh, that can't happen. But you can't really make that call until the absolute value is by itself. Because on my very first step on solving this, I would add 5. And once the absolute value gets isolated, it actually is going to equal a positive number. And then that's okay, because that's the stage where you separate it and you'd say 2x plus 4 equals positive 3, 2x plus 4 equals negative 3. And then you'd have some answers on both of those, and that would be okay. You can't make that call and about it equaling a negative, and that would have to be a no solution. You can't make that call until the absolute value is totally isolated. This is the stage right here where you'd make that call. All right, hope this helps.